Okay, well, it's a pleasure to be here, and maybe as Chris was saying, let me add evidence that cloud is becoming a hot subject. When Chris contacted me and said, we're going to have a discussion about cloud at the Bank Inter Foundation, I said, well, that's really nice. And we were just going to talk about the agenda. And then I asked Chris in passing, when is the meeting? And he said, first week in December in Madrid. And I said, gee, that's interesting, because I'm scheduled to go to Madrid the first week in December to give a talk on cloud computing to Telefonica, which is, unfortunately, I have to leave around 11 o'clock because I have to go to Telefonica to give a talk. And he said, well, we are about the same time, so maybe it's just the way the Lord works that on the same week I'm giving 2 cloud talks on the same day in cloud computing in Madrid. And I think it's a sign that this is a hot subject. And of course, the question is it not just a hot subject, but is there substance behind the hotness, or is it just hype? And I think that's a lot of what we'll talk about. And needless to say, I have drunk the Kool-Aid. So I'm going to try to convince you that, well, I don't think I have to convince many of you, but I'll give you my argument why I think this is a big deal. And I want to do that by talking about these 4 areas. What's the market environment that is welcoming to cloud right now? And then I'll give you my own definitions of cloud computing, cloud adoption strategy, benefits, and so on. And clearly, I have a lot of slides. Clearly, Chris, this is all about having a discussion, not me giving a presentation. And I've already been talking to quite a number of you yesterday at dinner, this morning at breakfast. So I know many of you have very strong opinions. So bring them out as I'm talking. So market environment. And I want to focus on 3 critical parts of the market environment that are part of why cloud is so important. The digital technology revolution, the focus on services that is so critical, and this notion of convergence of physical and digital infrastructure. I'm going to go very quickly through these slides because everything I'm going to say, or most of them, you know well. The fact that there is a digital technology revolution, I don't need to say anything. The internet showed up. There goes the industrial age. We're into something else. I have no idea what to call it. Knowledge age, information age, services age. And all of a sudden, we can start looking as digital systems, lots of things that in the past we couldn't. That's, in my mind, that's sort of the essence of what has changed as a result of this digital technology revolution. We can apply system thinking to many, many, many more problems than we ever could before. And I'll talk about that as we go on. I think that's a huge deal. Now, second is this whole emphasis on services, because as I will talk about later, I really think of cloud as focusing on the consumption of services and the delivery of services. So the question is, why the hell are services so critical? Well, the answer is it's the bulk of the GDP of most of the world. This chart applies to the US, and I went to the CIA World Factbook actually does a tremendous analysis, a tremendously good analysis of lots of economic factors. and you can see the details of this US GDP composition. The labor force, it's not quite identical to GDP, but they track very closely, and you can see that, again, close to 80% of jobs in the US are services. And notice, sometimes when you talk to people about applying technology to services and improving productivity and quality of services, they say, well, services, you know, my gardener or my nanny. That's true. Gardeners and nanny are services, so are the cooks in the kitchen here. But those services are more in the 16.5% other services. Look at the two categories above, which come from the classification of this World Factbook: managerial, professional, and technical, sales, and office. All those services are superb candidates for applying technology to. That's why that is so incredibly important. So the vast majority of services, about almost 80% of that 80% of GDP, are candidates for applying technology to. And if you look at, I went to Wikipedia and I looked at the latest GDP numbers of lots of other countries, and you can see the US is a little higher, but you know, if you look at the average in the world, is 64%. Spain is close to 70%. The European Commission in general is about 70%. So this is a really big deal, working on the services part of the economy, because it's the largest part of the economy. Remember also that for the US, for Spain, for many countries, there is nothing more important than job creation. Nothing more important. I think if President Obama wants to be President Obama for 8 years instead of 4, job creation is going to be everything. I mean, Afghanistan is important and healthcare is important, but jobs is really, really important. And I'm sure the same is true in Spain, that job creation is critical. And a lot of the reason for thinking hard about how do you apply technology, innovation in services is also thinking hard, what new categories of jobs can we create? Now, why, by the way, just as a very simple point, why are the bulk of the jobs in services? Well, the reason is very simple. During the Industrial Revolution, we applied technology and science to the industrial sector of the economy and to the agriculture sector of the economy. And as a result of that, the productivity in those sectors went up tremendously, whereas the productivity of services is not good at all. That's it. So we have proof points, the Industrial Revolution, that science and technology work in bringing productivity and quality to the economy. We just haven't done it to this next gigantic sector that is services. And I think everybody would agree with this point, but I think that's a huge context for cloud. Now, what new capabilities do we have to now apply technology to services? And I mean, yes, we have the internet and all that, that's very good, but even more is what digital technologies and so on have been given us in just the last few years. Gigantic amounts of information. This is really important because, as I'll talk in a second, to do things in services, you need to do things in real time. You need to figure out what's going on. Services are different from things. A plane is very complicated, but it's deterministic. That is, if you tell the plane, this is what you are, the plane doesn't argue with you. It's happy to be whatever you design it to be. If Chris is putting together an organization full of people, and he says to those people, this is what you are, they'll say, wait a second. That's what you think I am. So when you're dealing with services, which are all composed of people, it's an incredibly more dynamic and changing system than the classic physical systems we're used to from the industrial age. And the only way to do something with dynamic, fast-changing systems is to get real-time information, analyze it in real time, and take action. And that's why these things are so critical, that for the first time, we get gigantic amounts of information, we have mobile devices, we have trillions of sensors, we have all the computing capacity. That's why the things you showed about the supercomputing show are so important, because, I mean, in order to analyze things in real time, you need fast, cheap computing. Well, guess what? We have fast, cheap computing. So we have the wherewithal to do all that. And just as background, what do we mean by we can put digital components everywhere? And these are just some slides that I borrowed from my colleagues in IBM doing the whole Smart Planet initiative. The most boring usage today of IT is in IT. Because in fact, what's happening with IT is that with digital components is that they are being embedded into everything. The world around us is now becoming digital because we are embedding digital components into the physical world around us. We can get information, optimize it. IBM has this Smart Planet initiative to go develop this kind of real-time systems. HP, Chris, where is Chris? You called it what? Sense? What's your equivalent initiative? Yeah, so you know, everybody's moving in this direction, and you know, these are the kinds of applications that IBM is looking at: Smart Planet and smart cities and so on. So that's the environment of this gigantic digital technology revolution, the huge emphasis on services and how we apply this technology to services, and the fact that we also are taking this technology and integrating it into the physical world around us. So that's the background. Before I now move into how I think of cloud computing, any comments or dialogues on this framing? So far, so good? Okay, so what is cloud computing? Well, what is happening is, as a result of everything I've just been talking about, we see a whole set of workloads that are exploding. And what do I mean by exploding? Volumes 10 to 100 times bigger than what we have today. So, I mean, lots and lots of things. And I don't mean every aspect of computing is exploding. You know, banking transactions are not exploding. They are growing by whatever they're growing, but they're not exploding. But needless to say, given the explosion of all these mobile devices and sensors, somebody has to manage the damn things. And the management of those things is one of the applications that is going up like crazy. All these smart applications that are sending information and congestion management and tracking cows and no, that's a real application. You put a little tag when they are born and you take them off when they become a steak, which is, by the way, which is very important because of any potential food problem. If there is ever a food problem, you want to be able to trace back where it came from, and if you have the right tax and the right management of information, you do that. So that's a real application that a lot of people are doing. That's doing things. Gigantic number of business services, consumer service. Think of Google Maps as sort of the quintessential new consumer service to mobile devices, and then all the social media applications, all the virtual world, immersive applications. I think you will all agree those workloads, I hope you will all agree, are absolutely exploding. Those are really going way up. And what's the problem? Well, the problem is our IT systems, our models of computing, the central model or the client-server model, which I'll talk in a second, are not up to scaling 10 to 100 times. They just cannot do that. And if somebody said, well, we'll just keep adding labor and so on, well, first of all, if you keep adding labor, which is the way we often get around the problem, everything becomes much more expensive. And you can only add labor up to a point. Maybe if it's scaling twice as much, maybe you can make up the things with labor. But when you go up by 1 to 2 orders of magnitude, you have to restructure and re-architect. You cannot do things the old way because it just isn't going to work. And what we need is a new model. We need to think of what's the right model for people to consume all these services, and for the services factories, that is the data centers, to deliver all these services. That's what we have to think through. If we are going to be surrounded by this gigantic number of services, what in the world do we do? That's cloud computing in my mind. That's the essence of cloud. It is a consumption model for all these services based on making it far easier for people to consume them, and it is a delivery model of the services, making it far easier for the data centers to deliver them. That's it. That is, in my mind, the essence of cloud computing. But this is a huge deal, because if we don't make major progress in the consumption and delivery of services, we'll have chaos. Or let me say it a better way, we'll have more chaos than we already have in the IT world. So at another level, Chris, this is cleaning up our mess. We have had a really messy IT world, and we're now trying to clean it up so we can move on. So I'm just saying the same thing. At the consumption level, it's mass customization of services. By the way, mass customization doesn't mean everything has to be identical. I think websites are a superb example of mass customization, meaning 90% of all the machinery in websites is identical, but if somebody says, gee, I don't like purple, can you make it red? Sure, you can have it in red. If they say, I don't like HTTP stacks, can you do something else? The answer is no, shut up. You want a website? This is very important, because sometimes people hear mass customization and they think everything is identical. A Google map, the underlying infrastructure is the same, but you can put in your own direction. Google doesn't say, I can only work if you want to go to the Museum of El Prado. It's going to take you anywhere, but you cannot go in and say, I don't like the user interface. The answer is, well, screw you. Then don't use Google Maps. And on the delivery side is industrial. No, this is a very big deal because you don't realize how incredibly ugly IT applications are until you start thinking about them from a user's point of view. They are really ugly. They weren't ugly when many were first developed 25 years ago. 25 years ago, think about the world 25 years ago. It was very different. ERP, R3 was designed 25 years ago. I don't know if anybody has met a client who likes R3, but in its day, it was a major breakthrough. That's still what we use 25 years later when the underlying components have advanced 7 orders of magnitude. So we have really ugly applications, and we're trying to industrialize applications. So cloud is very much along this path of we had centralized, we had distributed, then the internet showed up, it started to give us all kinds of things, and now we're moving into the cloud era. And I really look at it as a new model of computing that is sort of the evolution of the previous 2 models. By the way, a new model of computing is a very big deal in my opinion. We've only had 2 in 50 years, so they don't show up that quickly. And the key to the cloud model is that it's the first model that is totally based on internet architectures. Client-server was based or is based on PC architectures, just like the central computing is based on mainframe architectures. Cloud is totally internet-based. Now, is cloud for everything? Absolutely not. There are many, many applications that you shouldn't touch with cloud. Jaime yesterday mentioned some of them. You have mission-critical data for the next few years. Don't touch them in the cloud. Keep them wherever you're happy doing them. So lots of applications that require tremendous security, mission-critical, whatever, keep where you have them right now. Don't touch them. But there are many other applications, almost all of them, the applications dealing with market-facing things, with people, with sensors, with things like that. Those are the ones that cloud is best for. Just as a trivial example, there is a huge difference between storing your banking account and storing your digital pictures. Your digital pictures is a great cloud application. Your banking account for the foreseeable future is not. That's a very important thing. And another way to look at it is classic database, transaction, mission-critical application are not candidates for cloud. They are candidates for more SMP, scale-up kinds of computing, which is what we do today. I mean, for the next few years, who knows, 5, 10 years from now, the ones that are really the great candidates for cloud and the ones people are applying to are applications that are massively parallel, that are massively scale out, that are very web-based, very mobile-based, lots of information to analyze, search, find things, maps, MRI processing, genomics, personalized medicine. Lots and lots of these applications are excellent candidates for cloud. So this is very important because otherwise people start arguing with you about you want to put my bank account on the cloud. And I said, I don't give a shit where your bank account is. That is, I mean, of course I do. That is not a good cloud application. But many, many others are. And IBM has done some surveys. These are some examples of things that have come out, and it's what you would expect. Are applications dealing with service and mobile devices cloud applications? They're wonderful cloud applications because there are so many of these, and you don't want the image of the mobile device to reside in the mobile device, because if the device gets wet, you don't want to lose everything. You want the image to reside in the cloud and come down to the device. That's one example. So lots of desktops and things like that are great cloud applications. Why do people use cloud? Let me finish quickly with that. On the data center side, it's because as data centers have to, or those portions of data center supporting these workloads that are exploding, the hardware side is a piece of cake because we have Moore's law helping us. So hardware keeps getting cheaper and cheaper and cheaper. System management costs, if you're not careful, are exploding, and so are energy usage costs. So not surprising, if you look at companies like Google with their massive data centers, Amazon, Microsoft now with Azure, MSN, IBM with its data centers, I'm sure it's true for HP in the cloud you're building. This how to build data centers that can handle these volumes and the energy they need is a huge deal. Now, why is this such a big deal? Most data centers are a dog's breakfast at best. They are really inefficient. Google's is great. Why? Because Google has the equivalent of Prussian generals managing their infrastructure. They kill you if you thought that. They say, no, Google, you can do whatever you want to. Bullshit. You can do whatever you want to in certain parts. The management of the data center, and I mean that with tremendous respect, is about as disciplined as it comes because of the huge volumes they need to support. So everything is incredibly well engineered. We've done studies, and the benefits are really palpable, that you can get orders of magnitude improvement in the costs. Remember, we're talking about scale-out workloads. I'm not talking about transactional applications. To support these things, if you have a highly utilized cloud kind of architecture versus a traditional architecture. And a lot of it is just cleaning up things we should have cleaned up years ago, like don't run client-server systems at 15% utilization, which is not atypical for client-server systems. So a lot of it is just finally cleaning up the mess that most data centers have inherited from client-server days. That's a lot of why the benefits are so palpable. And it's not just consolidation. It's also very, very disciplined system management and so on. In addition to this infrastructure leverage, there are also lots of labor leverages. If you design, for example, most PC applications are very labor intensive for the user, and also you need a support staff because they were designed 20 years ago. Most mobile applications, you can have a support staff. So they have to be designed to be much easier, much more elegant, so that they are self-service. And so a big part of what you need to do with cloud applications is make it as self-service as possible, automate the management, and standardizing. And you cannot do that later on. I think that this is going to, just like we have the notion of design for manufacturability, we need the notion of design for ease of production. And if you don't design it that way, you're going to be in really deep trouble. And I've studied a lot what Google does. That's an area they've done incredibly well. They have application images. If you want to write an application to go on their centers, it has to be written to their application image. If you do that, it minimizes the testing because it's so controlled, and you can get it to production and to scale far faster. In most companies, it takes months of testing to get an application in production. So there are lots and lots of savings here. There isn't going to be one delivery model. There are going to be multiple delivery models. Most of the interest has been on public clouds, like Amazon's elastic computing, but that's because those are more consumer-oriented clouds, and most consumer-oriented clouds are public clouds. Within businesses, and I'm including government and healthcare and so on, a lot of clouds will be internal to the business. That is, if cloud is a very engineered way of running a data center, it doesn't make any sense for a business to say, well, I'll continue to run mine the crappy old way, and I'll outsource everything else. So a lot of businesses are going to re-engineer those portions of their data centers and effectively run their own clouds. Perfectly fine. And that may be how, over time, they evolve their more mission-critical information to cloud because they'll run it themselves. And they will only go to public services when they need to. A lot of businesses also need to really make sure that when they say our people know how to run security and privacy better than other experts out there, that it's true, because often it is not true. So I think we have to be very truthful, and all these things will coexist with the classic systems, which will be mostly in the back end. Lots of challenges and so on, but it's happening.